Hello, everyone. Welcome to 24 Hours of Pass Summit Preview 2015. We're excited you could join us today for Kendra Little's session, Taking the SQL Server Index Quiz. This 24 Hours of Pass event consists of 24 consecutive live webcasts delivered by expert speakers from the SQL Pass community. This session preview is one of many technical sessions that will be presented at Pass Summit in October this year. Recordings will be made available in 1 week at www.24hoursofpass.com. My name is Oliver Asmus. I am a database consultant with Slalom Consulting. I've been working with SQL Server now for about 10 years, and I have a few quick introductory slides before I hand the reins over to Kendra Little. She will speak for about 40 to 45 minutes, and then we'll move on to QA.
Well,
Next
slide.
Perfect. Technical assistance. If you have any questions or if you're experiencing any issues, just type your question into the question pane on the GoToWebinar control panel and someone will assist you. Feel free to enter your questions in the QA field at any time. Once we get to the QA portion of the session, I will read off your questions to the speaker. Since all attendees are muted, you will need to submit your questions by typing in the QA field. Also, there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will appear in your web browser. I'd like to take a moment to thank our presenting sponsors, Microsoft, Dell Software, and Idera. In addition, I'd also like to thank the supporting sponsors for this event, HP, SequenTree, and Pyramid Analytics. The staging of 24 Hours of Pass would not be possible without their support and dedication, and they are the reason this event is available free of charge. Next, I'd like to bring your attention to the upcoming Pass Summit, taking place in Seattle, Washington from October 27th to the 30th. Pass Summit 2015 will feature over 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community for the SQL Server community, Pass Summit is single-handedly the largest gathering of SQL Server and BI professionals in the world. With over 5,000 registrants from all over the world, Pass Summit is also a great place to network and meet face-to-face with experts, peers, and MVPs. More importantly, Pass Summit delivers on providing you with the answers to your SQL Server issues, along with the knowledge, strategies, and skills you need to stay ahead of the curve. Save $200 right now by using the discount code 24HOP15 when you register. Optimize your savings by registering before the end of Sunday, September 20th. To find out more about the Pass Summit, please visit www.passsummit.com. Make sure you explore everything Pass has to offer for data professionals. You can join local user groups from around the world, virtual chapters, find free online resources through our Learning Center, and read up on the latest community news in the Connector newsletter. For those interested in business analytics, check out the Pass Business Analytics Conference happening in May of next year. Visit www.passbaconference.com for more information or to subscribe to our bi-weekly BA Insights newsletter. Take it away, Kendra.
Thanks so much, Oliver. That was fantastic. Hey, folks. I am Kendra Little, and I am going to give you guys a chance to take the SQL Server Index Quiz today. Now, I love indexes in SQL Server. They are a fantastic tool for making your queries run faster and for making your SQL Server go farther. Get the most out of your CPUs. Let your storage take a little rest. By optimizing indexes, you can help your SQL Server do more faster using less. They're really this magical tool. But knowing exactly what indexes to use and how to structure them and what to use them can be really, really tricky. And I think that the best way to learn about indexes in SQL Server is to just repeatedly work through problems. This is not only really great training, it's also really fun. And the types of problems that I particularly enjoy and that I use the most so that I can learn more about indexes and also teach people more about indexes. I love to really just challenge myself and say, oh, for this query or this set of queries, what's the best index? And why is it the best index? Why don't other indexes work quite as well? And how do we figure out what the best index is? Similarly, if I have this query and I have this index, can it use that index for the query? And I also really enjoy quizzes. So what you're going to see here today is kind of a combination of these. We, in this hour, are going to do 6 questions in a SQL Server index quiz. And I want you to get your pen and paper, just scratch paper, doesn't have to be anything legit, and a pen. Just you want to be able to write down what you think is the correct answer, and you want to commit to it. Don't just look on it in the screen and think maybe it's A or B. Commit to what you think is the right answer, and then check, did I get it right and why? And the cool thing about this is that I have the results for how 3,400 other people did on these questions on this index quiz, because I've asked a lot of other people these questions, and you'll be able to see if you write down what your answer is, hey, how did they do, and how does that compare to me? And it is always kind of compare yourself to other people, right? Now, don't do it in a bad way. Don't, if you get it wrong, don't beat yourself up. The whole point is that you're trying, that you're improving, and that you're getting better, right? So have some fun with it. And I do want to give a shout out to a guy named Eric Darling who helped me write a lot of these questions. And if you think some of the answers on these are funny, it's probably Eric's work, right? So anything clever and funny, I got to give a shout out to Eric because he really helped me out with these questions. So ready for question number 1, right? Got your paper, got your pen ready. Question 1. When you create a non-clustered index in SQL Server, the size of the included columns in the non-clustered index counts towards the 900 byte size limit. Is this statement true? Is it false? Or is the answer potato? So write down, take a minute to look at it again. There is a 900 byte size limit when you create a non-clustered index, but does included columns count towards that? So take a moment, write down, commit, pause for a sec. All right, you got your answers. Let's think about this and think about indexes. So we're kind of starting sort of foundational here. When you create a non-clustered index in SQL Server, it uses a balanced tree, meaning this page at the bottom here, the root page in the index, the path that you traverse from that to that big top level is going to be even no matter which intermediate page you go through, right? If there are, and it is an if, depending on size, if there are intermediate pages, 1 or more level, you're always going to have sort of a balanced route out to the leaf. Now, in a non-clustered index, you do not have to use included columns, but you can choose to. And if you do define included columns, they are kept up in that leaf level only. The key columns are at the root page, intermediate pages if needed, as well as in the leaf. And that 900 byte limit actually applies to the root and intermediate pages, just to the key columns. And if you think about it, this kind of makes sense, because if we let indexes have really broad keys, what would the shape of this tree be like? Would it really be a tree at all? We'd have a root, but then it would just sort of, right, it wouldn't really be a tree. The limiting of the size of the key columns does mean that the number of intermediate pages, yes, it can grow large in a large index, but it is actually defined and has a limit, whereas we can add many, many included columns well over that limit, and our leaf could grow very, very large if we packed it full of included columns. So how did folks answer? Well, looking at this, 40% of people said it is true, and that's not right. The correct answer is false. The size of the included columns does not count towards that 900 byte size limit. It's simply the key columns. So you've got, if you got fooled and you said true, don't worry. A lot of other people got fooled too. Now, one of my favorite things about this quiz, if you look at the answers here and you think about the fact that 3,400 people answered at the time I captured this information, you'll know that at least 100 people answered potato to this question. So if you did happen to answer potato, you're in You're sort of a small special company, right? But you're not actually alone. Potato is a compelling answer to this question to some folks. Folks who did still complete the quiz, right? Like they were still invested, right? It's funny. Thinking about this too, I mean, the fact that we aren't limited to 900 bytes for the included columns, well, what does that mean about index design? Should I just put all of the included columns from the table as included columns in case they need to be used? Well, not necessarily. And I talk more about this in the pre-con that I'm going to do for PASS, and we'll see a little bit more about it here. It does matter how many, SQL Server does think about how many pages you have in an index. And making, adding lots and lots of included columns can vastly increase the size of our non-clustered index, which can decrease its efficiency and not necessarily help our performance overall. So we want to be cautious and have balance and think about a lot, and only add included columns if we really need it. All right, question number 2 out of 6, 2 out of 6. So this one, I love this one. Can SQL Server use this index for this query? So looking at the index definition, the index is this is using a sample database from Stack Overflow, the popular question and answer site. They allow folks to download the data from that, and you can actually load it into a SQL Server database and use it to run test queries, which is really, really fun. The post table in Stack Overflow contains both questions and answers. Those are all considered posts. This index, IX creation date, is on the post table, and it just has a single key column on creation date. It has no included columns. So we have just a one column non-clustered index. Our query is a little bit interesting. Our query wants the top one row only for the creation date column from the post table, where the year of creation date equals 2012, and then it's going to order by creation date descending. So it really just wants the max date, but it's writing it in a format with a top and an order by. So can SQL Server use this index for this query? Your options are no, it can't, because there's a function in the where clause. You might think B, no, it can't, because the index is not descending. And notice, this is true. When I create the index, I haven't specified ascending or descending. It's going to default to ascending. You might think that it can seek, or you might think that it can scan. So take a minute, review your options, and then pick and commit to what you think it can do, and then we'll look at the answer. All right, commit to your answer. Here we go. So looking at the index, yes, it's an ascending index. It has one column on creation date. Does the fact that the index is ascending and the query is descending, does that alone mean that it can't use it? In fact, SQL Server can read backwards. It is able to go to either end of the index, and it can scan forwards or it can scan backwards. So the simple fact that the query is descending and the index is ascending doesn't mean they're completely incompatible. There is a little bit of trickiness to this. So it is true that there are some limitations for backward scans. The part of the query plan that's doing the backward scan, it can only ever do it with one thread, right? It can't go parallel just for that zone of the query. Other parts of the query could potentially go parallel. But in our case, we just want one row, right? So if we were able to go just to the end of this range and then go backwards, in theory, if we could do that, we wouldn't necessarily need a lot of threads, right? So the fact that these mismatch, it does make a difference, and it's worth knowing about, but in this case it doesn't, it's not a good bet to say, hey, it's just totally disqualified. Looking at the query further, the query in the select clause and in the where clause and in the order by clause, it's all just using creation date. We don't have any other columns in there. So yeah, the index is only on one column, but the query is only using that column. So the query, quote unquote, does get covered by the index. It's not like the query is referring to other columns with a predicate or anything like that that aren't in the index. So that is actually pretty promising. But the function is still concerning. Functions are sort of famously suspicious in SQL Server, And whenever we see a function in a where clause, and further when the function is around the column name in the where clause, in other words, the function isn't on a parameter value or a constant value, it's on the column itself, this may mean that SQL Server may have a problem. And this is the point where if you're a gambling person, you start saying, man, it may not be smart enough to seek on that. I think that because the index covers the query, it may be able to scan it, but it may not be able to seek on it because functions often trip it up. And this is, based on experience with SQL Server that would make you guess this, right? A lot of this is experience-based. So here's how the answers came in. The correct answer, and I'll prove this in a sec, the correct answer is yes, it can scan that index. Now, 39% of the people have been burned by functions before. And I don't blame you guys. Like, functions equal suffering is something that after a while we get associated with, like, just, the function's going to mess us up. 2% of the people thought it was the order. 18% of the people, and I love that 18%, if you answered yes, it can seek, optimist. It's like a personality test. And optimism isn't bad as long as you're able to verify it later. So don't feel bad if you thought it could seek. But the answer is, in fact, that it can't seek, and if you do have to bet when a function's involved, yeah, pessimism is probably makes a little sense. So let's take a look at what happens here. And what I've got on the screen here is just a screenshot of actually two different versions of this query. So the first query on the screen is the one I showed you earlier. The second query is just rewriting it with a traditional max because I wanted to show you, does it do something different? And what I did is I looked at this in two different ways. I used the SQL Server statistics IO command and ran these to see how many logical reads they did. And I also looked at their execution plans. Their graphical execution plans are displaying below. The first query, the one that we're talking about and that we're really interested in, the top one max date, note that it says it's doing a non-clustered index scan. Yeah, it's not doing a seek. The function is messing it up. It is doing a scan, but here's the interesting thing. When we look at the number of reads that it's only doing 8,700 logical reads. And if you scan the entire non-clustered index, which I tested by doing, a select where, just select creation date from posts and made sure it was using the index, scanning the entire non-clustered index is far more reads. It is smart enough, because it knows this is a date-time column. It is smart enough to be like, well, this part of the table probably has the 2012s in it, but it's not smart enough to figure out that even, that it really just wants one row at the end to it and that it could do a seek, because they are in order, right? The same thing is true of the second query, which is using the max also with the function. It still has 8745 logical reads. It does get a slightly different execution plan in that it throws a stream aggregate in, but they both do the same amount of logical reads. If we rewrite the query in this way, so that we are not using the function around creation date and are saying creation date in this range and we want a max, that actually, the function's gone and SQL Server's like, woo, I get it. And it is able to do a seek and 3 logical reads in that case. The point I want to make here is actually, yeah, the function isn't great. It is completely true that if we can rewrite our query, we can do something the best. But even if we can't all fix all the code in the application and we're stuck with functions in the where clauses, the index actually is able to be used in a somewhat smart way in this version of SQL Server. This is SQL Server 2014. With something like this, I'm always like, test how it works on your exact version and patch level of SQL Server, because things may shift in overhead bins while the airplane is in flight, right? And this is one of those little things with functions where you're always better off if you can avoid using the function, but you may be able to pull in some indexing tricks to reduce the pain even if you can't change the code. All right, question number 3. So 3 out of 6, we're almost halfway there. And this is, again, is this statement true or false or only in some situations? So the query optimizer knows how fragmented an index is. Is this true? Is this false? Or is this only true in SQL Server 2014 and higher? So go ahead, take a moment, think about it. Does the query optimizer know about fragmentation? Pick your answer and commit. Write it down. We'll talk about it. All right, I see everyone putting their pens down in the distance. There's a lot of things that the optimizer doesn't think about. When optimizing a query, not everything comes into play. And part of this is we have to optimize something quickly. So there's always a battle between how fast can I optimize and quality of optimization. We really, we want to do good, but there's some things the optimizer doesn't think about. And the first one on this means if a query comes in and there is really only one way it can be run, right? There's not really any indexes to choose from, right? Like, let's say a query comes in and it's a query that references one table. The table doesn't have any indexes, and the estimated cost for the query to run it with a single thread is nowhere near what it would take to go parallel. So I don't have to think about what indexes to use. I don't have to think about whether or not I'd go parallel. There's just one way it can run. In that case, SQL Server will do something called trivial optimization, which makes sense. There's only one way it can run. It's trivial, like just go, like, right? And it wants to get that query out the door, like, go, query, go. It will not stop to ask for an index in that case. In trivial optimization, it never goes through the part of optimization where it would say, hey, an index would keep me from having to scan this giant table if it doesn't have any options. Once that query is running once any query is running, it never stops and compares, was my estimated cost right? Cost is always estimated before it gets started, so it never stops and says, ooh, this was way worse than I thought. Should I have used that index? No, it keeps going, right? Like, never looks at what was the execution times the last time it ran. It doesn't understand if you're running on SSDs versus spinning disks. Similarly, it doesn't know, is the data I want, is it in memory or is it on disk? The optimizer doesn't know that. It also does not know about index fragmentation. In other words, it does not know if pages in the index are out of order on disk, right? It doesn't know if it's going to be able to scan them off disk or if it's going to have to do random reads. And it doesn't know how much empty space is on the pages. So the optimizer doesn't know about index fragmentation. And it does I totally get, like 20% of the people were like, yeah, I bet it does. Those 20%, if you answered true, I don't blame you. There actually is something similar. And if you look at this 25% of the people were like, oh, maybe they added this in 2014, right? Like, I hope so. In fact, no, we still don't have this. But there is something similar, kind of, that the optimizer does consider. So there's a reason why you might think this is true. The optimizer actually does look at how many pages are in an index or how large is an index. This is why there's a couple different scenarios that you could do things with indexes that could confuse you. If you say, rebuild your indexes with a really low fill factor. I used to have my indexes with the pages really full, like 100% full, and then I did an alter index rebuild and I set fill factor to 10%. Suddenly, I have a lot more pages and 90% of them are empty. Technically speaking, the optimizer doesn't know that they're empty, but it does know that you have a lot more pages, and it might start considering very different query plans and doing different things based on the page count. Similarly, the example you've got on the screen, if I was to just compress, like use data compression, an enterprise feature on all of, say, my clustered indexes and shrink them down in my database, but I didn't compress any of my non-clustered indexes, in some cases, SQL Server might start making the decision, I'll just go scan that clustered index, when before this ratio changed, it actually was doing something different with the non-clustered indexes. So page size does matter, but it isn't considering whether they are out of order or whether there is empty space on them. So if you, thought it did matter, you're actually kind of close. Everyone can kind of win on this one. All right. Question number 4 out of 6. Let's say I have a lot of rows, or I have rows with null values. I have, let's say I have a 1-column index, actually, right? And the 1-column index is on a column that is nullable and can have null values in it. if I define that non-clustered index as unique, how many rows can be inserted into the table with a null value for that column? Is the answer 0? 0 rows? Is the answer 1 rows? Is the answer only that the rows can be null in unique filtered indexes? Or is the answer only that null rows can only exist in unique clustered indexes? So go ahead and pick your answer, A, B, C, or D. Write it down. I like to give a moment to think. All right, here we go. This question is actually a little bit controversial, and there can be sometimes heated discussions about nullability. I do not particularly have passionate feelings about this, but I understand that many people do. The way to remember this is that SQL Server considers null to be a value. In other words, null must be a unique value if it is a unique index. Now, some people are really offended if null is a value, but that's how SQL Server believes about it. I understand that, I understand that we can have strong feelings about data. So the correct answer to this is in a unique column that allows null values, you can only have 1 row with a null value in whatever criteria meets the index. Now, 26% of the people actually thought you couldn't put null rows in there at all. You can just put 1. Right? So 1 can get in. If you don't want a null row, you have to make the column not nullable. You don't want any null rows. The filtered indexes, a couple people thought, and the unique clustered indexes, some people thought, there is something with filtered indexes that is related to this. Filtered indexes can actually help solve this problem. And there's a lot of really cool things about filtered indexes. I love talking about these. Filtered indexes were added in SQL Server 2008 and higher. They are allowed even in Standard Edition. There are a lot of gotchas with them. They can even make inserts, updates, and deletes fail if you hit landmines with your ANSI settings or weird options like that. But they can do really cool things, and one of the cool things they can do is regarding nullability. So for instance, you can create a filtered unique index like the one you see on the screen. And basically, if the display name column, which is in the users table in the Stack Overflow database, if it lets people have, let's say it's fine if you have a blank display name, but if you do have a display name, we want it to be unique. We can enforce that by creating a unique filtered index like this that says I want to create a unique index on display name where display name is not null. I can now have multiple rows where display name is null because this index will not enforce uniqueness on them. It only enforces the uniqueness where display name is not null. Very, very cool trick. You can also use this index for queries, right? So it's not just enforcing uniqueness, it can also support queries on display name. You can even add included columns to it. So very, very cool. I love tricks with filtered indexes. But filtered indexes can be really confusing, hence question 5. And I love filtered indexes so much that I did 2 quiz questions on them. Look at the following filtered index definitions. 3 of them are invalid, 1 of them is valid. And you need to rule out the ones that are invalid and pick the one that's valid. So I'm gonna pause here for a second because you probably don't want me to read these out loud. And I want you to write down which of these you think will actually work. And actually pause. All right, pick your winning index here. So we're going to start moving through these and ruling them out and see which one will actually work. And I really think process of elimination is the way to go here. So this index, this looks good at first because it looks really basic. In the where clause of the index, we just have where creation date equals value. But this index is missing something really critical. I have not defined a key column. Filtered indexes will not let us create an index without a key column, right? We need a key column to put in that structure. A where clause is not enough, so this one is not a valid index, right? Next one. This one is really tricky. And this is not like it is tricky, but it is something that's worth knowing because this can be really confusing. This is a filtered index where the creation date is one value or another value. And if you try to create this index, you will get a syntax value error, and it'll say, hey, you can't do or in a filtered index. And that might seem kind of weird. It is just a syntactical thing. If you need to do something like this in a filtered index, you can actually do an in clause in the where clause of the filtered index, and queries that do ors, you might say, oh, I don't want to rewrite all my queries. Queries that do ors, if they match, can actually use the filtered index that has an in clause. So yes, it is true that you cannot do an or in a filtered index. This was not syntactically correct. However, it is important to know that there is a workaround, which is using an in clause in the filtered index. But this index won't work either. And finally, this index doesn't work either. You are not allowed to put functions in the where clause of a filtered index. It simply doesn't support that. And this might seem problematic. And I purposefully used the example of month because that one would seem like, oh, I'd really like to do that. But think about if we did allow functions and you had some functions that were like the date diff between now and the date of the row was some value, and as time passed, that condition changed. SQL Server would have to be constantly churning data through that index if as time passed, it changed. And so I can see why having certain functions like that would make it hard, but we don't have any functions that are allowed in the filtered index, right? So that one doesn't work. The correct answer is actually, and this can be a little surprising, you can do not equals in a filtered index. So the B, where you're actually saying where creation date is not equal, is actually the correct answer. And a lot of people were like, I think a lot of people actually picked the first one because the not equal seems like it's, wait, you probably couldn't do that. But in fact, you can do a not equals in an index. I do not people that choose potato in answer to this question, or there might have been some people who picked potato here. So there are a lot of pitfalls. Make sure to test, like the key to filtered indexes, test them in a pre-production environment, make sure inserts, updates, and deletes are still working. These can be really, really handy. All right, last question, 6 out of 6. And now we move on to another very favorite topic, indexed views. When you create an indexed view in SQL Server, which of the following tasks is required, no matter what? Like, you don't have a choice. You have to do this every single time. Is it A, you must make sure that all of the underlying tables that will be members of the indexed view have clustered indexes? Is it B, that you must create a unique clustered index on the view? Is it C, you must create a unique non-clustered index on the view? Or is it D, you must rewrite your queries to force them to use the view? So I'm going to pause and give you a sec again to write down your answers to these questions. Figure out what you think is required every single time you create an index view. So go ahead, commit to your answer. So there is one of these answers that I really have sort of like, I understand. If you answered that you must rewrite your queries to use the indexed view, then it may just be that you've used indexed views before and you're like, every single time. Now, technically, no. Technically, there is a feature where your query can match the indexed view and just pick it up without rewriting the query. But because of some of the ways you have to define index views, like you can't use count. If you're going to use count, you have to use count big. Well, how likely were you to use count big in your query before? And other oddities like that. In fact, sometimes you have to kind of coerce SQL Server to use your index view, sometimes even resorting to hints, right? So it can be really tricky. So technically, this is not the right answer, and there is a better answer. No matter what, when you create an index view, every time you must create a unique clustered index on that view, or it will not let you index it. the process of creating an index view, you have to create the view with schema binding, which I didn't even have as an option, but that is required too. So you have to say, I'm not going to change the schema underneath the indexed view. And then when you create an index on it, the first index you create must be a unique clustered index, which means some combination of those columns in the index view has to be unique. You do then have the option to put non-clustered indexes on your indexed view. Know that there are a lot of gotchas and that you can dramatically slow down inserts, updates, and deletes to the tables underneath the indexed view just by creating it. And also that, I mean, you just have to be really careful. And also that further layers of indexes can contribute to that more. I'm going to show in the index precon class a specific example that shows sometimes you have to have indexes on the member table that support the index view so that you don't get this sort of worst case scenario out of inserts, updates, and deletes because of the view. But you always have to have a unique clustered index. So the correct answer is B, create a unique clustered index on the view. A lot of folks think that the underlying tables have to have clustered indexes, and I don't mean that that's a bad idea. I'm not saying that they necessarily should be heaps, but it is not always a requirement. You also don't have to necessarily rewrite your queries to use the view. When done well, index views can be really, really magical. For certain types of queries, particularly queries that do aggregates, index views can dramatically reduce I/O and CPU and computational power for those queries. You've just got, essentially you're pre-computing data based on kind of a formula that you're putting in the view, and you can combine joins between the tables too. So when these are the right fit, they are amazing and can do things that are really almost impossible to do otherwise. But of course, features that are really cool, there's always a way that, you know, if you're not careful, they can go wrong. So you've got to make sure that they go right. If you liked these concepts that we talked about today, in the SQL Server Index Therapy session at the PASS Summit this year, I'm not going to be doing this quiz again, but the concepts that we touch on in the quiz, non-clustered indexes, filtered indexes, indexed views, all of those, as well as more query challenges. Can this query use this index? What's the best index for this query? What are all the gotchas that come with this stuff, and how can I avoid them? We will be taking a magical roller coaster ride through all things clustered and non-clustered indexes in that session. So it'll be, I think, tons and tons of fun. Do you guys have questions now? And now is a great time to input questions into that Q&A box. Oliver, do people have questions?
Right now, we do not.
Okay, so you've got to have some index questions. So I know there's folks still in the session, and the questions can be about stuff that we've covered, can be about other stuff too. So any questions you got about indexes, about SQL Server, it's fair game. I'm guessing Oliver will probably prioritize questions about indexes, but go for it. If you've got other questions too, then I'm pretty open to it, because we've got a few minutes here still. So very, very happy to answer questions if you've got them. All right, I can actually think of some FAQ. I'm trying to think. I'm like, what are the biggest questions that I get? So one question that I frequently get is it a bad thing? Like if I have clustered indexes and non-clustered indexes, a clustered index on a table and then I'm adding a non-clustered index to the table. Is it a bad thing if I want to put the clustered index key somewhere in the non-clustered index? Because people know they're related. And the answer to that is, it's not necessarily a bad thing. SQL Server won't store it twice. It won't duplicate the data. So if you've got any questions like that, totally fair game, or other stuff's fair game too.
So we have a few here. What should I do if an index I made to cover multiple queries is not being used by an important query without affecting others?
Oh, that's a fantastic question. So it sounds like the index is being used by some queries, and I'm trying to sort of interpret, there's some queries who are using the index, but an important query is not. Can I change the index to get the important query to use it without impacting whoever's already using it? Now this is particularly tricky, especially because let's say I have 3 key columns on an index, and I'm just going to kind of make up columns. So let's say on that post table, I've got, right now I have creation date first, and then display name second, and then post type ID third. So the index is primarily sorted on creation date, like whenever it was created, and then after that, it's sorted on display name and then post type ID. Maybe the important query that isn't using it, maybe the important query only cares about display name and post type ID. So it might, if it's just doing those 2 columns and the leading column is on creation date, it's like, oh, I could use that index, but everything is sorted by date first. So the only way I could use it would be to scan it. And that may seem to be a lot of work. If it's too many rows, it just may be like, well, I could scan it. If it has other columns in the select list that aren't in the index, it would be like, oh, I'd have to scan it and I'd have to then look up those rows in the base table. That's too much work. So can I just change the index? Well, if I change the index order, and if I take that creation date and move it later in the index, it might, in fact, what we don't know about those other queries is we don't know, do the other queries only care about creation date? Or do the other queries care about creation date, display name, and post type ID? If the other queries are actually doing predicates on all 3, and I reorder the columns, they might not care that much, right? Because they have predicates on all 3, and it could still use it if I reordered it. But if the other queries only care about the first column and I reorder it, they're going to be really upset. So to really make sure, are they going to be impacted, you have to actually figure out what those queries are. You can query your execution plan cache and say, I want to see all of the queries that are using this index. And there's a script that I give folks, and it is in the pre-con. If you search online for, and I'm trying to think what the keywords this might be, search for Grant Fritchie query execution plan cache. He has a good post on this where he gives a query, and you can look for certain syntax in the plan cache. The gotcha is you're going to get all the inserts, updates, deletes to the table too, and you have to sort out who are the queries using it. And also, if the queries are using recompile hints, you're not going to find them. But at least, because what you want to know is, are the queries currently using the index? Are they using all the keys, or are they only using one? So that if I do change it, am I going to impact them? And there's no great way to do that except kind of slogging through and finding them. So yeah. Great question, though, because that is really hard. It's hard stuff.
Okay, we have another one.
Cool.
What are your views on replacing near identical indexes in a third-party vendor application with a couple of indexes with includes?
Ah, that's fantastic. So what are your views? So let's say, so this is a tricky question too. So the question has just said third-party vendor app. There are certain vendor apps where really, like SharePoint, you are really not supposed to change the indexes, right? SharePoint basically says, hey, I'm SharePoint, I'm weird, I do SharePoint stuff, don't mess with me. Max.1, I do my own maintenance, don't touch. Just do what SharePoint wants. Other vendors are actually much more flexible. Some vendors say, hey, you can create non-clustered indexes, you can disable indexes. Some of them want you to not do anything at all. Now, one of the reasons you want to be really careful is you're going to want to upgrade this vendor software. And know that whatever you do when you release an upgrade for the vendor software, if you're creating indexes or even manually creating statistics, you could break the vendor's release. And you really don't want that to happen. So if you do choose to make changes, do not drop, even if they're okay with it, don't drop their indexes. If they're non-clustered indexes you want to replace, it is better for you to disable them and to create your indexes with something in the name as well as rollback scripts so that when it comes time for an upgrade, you can change it around. Now, many vendors have access to the client SQL Server database, and if that's the case, you really need to make sure it's okay for what you do. Also know that if you accidentally disable a clustered index and not a non-clustered index, if you disable a clustered index, the whole table becomes unavailable. So don't do that by accident. But yeah, my view would actually vary based on the vendor database, just because some databases are much more don't touch this than others type thing, and for good reasons. You know, like SharePoint is designed in a really specific way to do SharePoint things. It's always worth checking too, because some vendor tools actually have a place where they want you to create indexes actually in their application UI. Some of the Dynamics family, actually, they're fine with you creating indexes. They just want you to do it through GUI. So it's worth double checking on that. Yeah.
Okay. I've got a couple people asking this question. How many indexes is too many indexes on a table?
How many indexes is too many indexes on the table? How many scoops of ice cream is too many scoops of ice cream on the ice cream cone? I actually do kind of have an answer to this, but I will say that my answer to how many indexes is too many is one that I'm kind of flexible with and sometimes will break. I typically get worried about the number of indexes on a table somewhere around 7, right? Somewhere around 7 non-clustered indexes. I'm like, that's a lot of indexes. Now, if the table is particularly large, like, and not everything is measured by number, right? I could have a very small table that is read an awful lot and is written to hardly ever. If I have a little bitty table like that where everybody wants to read it and nobody ever wants to write to it, I might be able to create 15 non-clustered indexes on it and they take up 10 megs of space. So my overhead, like when I think about how many non-clustered indexes is too many, I'm really thinking about how often am I going to have to write to it, how much space is it taking up in my memory, which is a precious resource, and my backups and my check-to-be and that kind of thing. So if it is a really little bitty table with really low writes, hey, you know, create your index party. If it's a really large table with a lot of updates and you've already got 50 gigs of non-clustered indexes, and now 60, and now 70, now like size all together, like each non-clustered index is at least 5 gigs, maybe 10, maybe 15, I would get nervous way before 7, right? Because I want to try to consolidate and things like that. So I do have that number, but it really, you know, how seriously I take it, you know, it is kind of measured by, you know, sort of index weight as well as insert, update, delete speed. How much do I have to maintain it, and how much memory and disk space and energy does it take up? Yeah. Also, filtered indexes can be lighter than other indexes. Of my indexes, if some of them are filtered, they might be dramatically smaller, and the amount they are filtered on may not get as many inserts, updates, and deletes as others. So I would kind of count those slightly differently too. Yeah.
Okay, I think we have another here. How often should we monitor index fragmentation on a production server, and are there any best practices along those lines?
Now we're really like getting into like take off the gloves. So index fragmentation is no matter what I say, someone's going to say I'm wrong, and I'm okay with that, right? So just know this is like super controversial territory. How often should I look at index fragmentation? Well, so a lot goes into index fragmentation, and the first thing I would just think about is how much of an impact is there when I do index maintenance. If you have SQL Server Standard Edition and you don't have a maintenance window at night, and you know you can't do a lot of I/O and CPU activities just on a weeknight, I wouldn't look at fragmentation on that weeknight just because I can't respond to it. In SQL Server Standard Edition, I do have an option called Reorganize, which can defragment indexes online, but it's single-threaded, and it can be a little slow, so I might not want to do that for all of my tables in SQL Server. In Standard Edition, I can also only do an offline index rebuild, which means nobody can use the table while the rebuild is running. So only look at fragmentation in the windows where you might actually do something about it. Either you have a maintenance window and, you know, it is going to do a lot of I/O and CPU at the same time. I do think index fragmentation is necessary, but can be overdone, particularly if you're in it, you have an availability group, database mirroring, or a very small maintenance window. You can easily make it run too long and impact your availability, so you kind of want to be cautious and sort of say, okay, I'm gonna maintain this on a regular basis, but I'm gonna try to do small chunks of work and keep it within my availability window, which means using some sort of script that does check fragmentation and only works on things that are fragmented perhaps has a time limit and says, I'm not going to run forever. If you've got a long maintenance window, though, and it doesn't matter, you know, if people literally aren't using the SQL Server for like 6 or 8 hours every night, you don't have to be that careful as long as your maintenance finishes within that window. So the more forgiving your maintenance window, the more you can do and the less you have to worry about fine-tuning it. And then the lower your maintenance window is, the more careful you have to be. Yeah. Even online index rebuilds can cause significant blocking. Even in Enterprise Edition, the end of an online index rebuild has to get what's called a schema modification lock, and that can cause significant contention. So on very busy systems, it can be very, very difficult to do index maintenance. There's an improvement in SQL Server 2014, which is awesome, called wait at low priority. And it means that at the end of your online index rebuild, instead of blocking everyone behind it, it can at least wait and hang out until it can switch things in and you get to tell it how long to wait to. So sometimes your edition as well as your version of SQL Server can play into what you can do to help be able to do it a little more often without causing chaos. Yeah, it's tough though. It's a complicated, that's its own hour presentation, so that's kind of my 2-minute version. 2-minute version of that. Do we have other questions? Is there more stuff?
Yeah, there's a lot.
Cool.
I think we have time for one more or two, but what are considerations for whether or not to use column store indexes on a fact table in a data warehouse? And this question is for SQL 2014.
Awesome. Okay, and so with column store is very, very cool. New technology. SQL 2014 lets you have the option of clustered column store, and you still have non-clustered column store as an option there too. So column store indexes are kind of like the magic sauce because you did say fact table. Column store indexes are great on fact table. So consideration one, do you have Enterprise Edition, right? So you've got to have the dollar signs for the feature because it is an Enterprise Edition feature. What you want to look at, and there are kind of separate, it is still recommended that if you're going to use column store, you are better off using table partitioning. And table partitioning often works super well with fact tables. And the reasoning is that, so non-clustered column store, a non-clustered column store index makes the whole table non-writable, but you can still switch in new partitions. Even with clustered column store, the recommendation is you are actually better off still doing the partitions and switching things in, because yes, you can update a clustered column store table, but if you have to do a lot of them, it uses this thing called the delta store and a tuple mover, the name of which I love, and it can actually get really behind if you do a lot of modifications and your performance can degrade over time. So look at how many rows are changing in there. Can I do partitioning on the facts table and switch in chunks, and then just start testing and see how are my queries running, how are they doing, and can I get the performance I want out of it. A very, very cool new technology. The number of rows matters too. I mean, you said fact table, so I'm sort of assuming millions and millions and millions of rows. You could conceivably have a small fact table that wouldn't work well. You really want millions and millions and millions of rows for column store to work well. So row count, can you partition it and move in chunks, which works particularly well with it? What is your partition size going to be, and how well does that work with it? Those are the things I'd think about. But yeah, prototype it out and test it. It could be very, very cool. Yeah.
All right, I think we have time for one more. In an Enterprise SQL Server 2014 edition, what can be done about an index that becomes fragmented too quickly? For example, 2 days.
Okay, so what can be done about an index that becomes fragmented too quickly? I would first look at what do you mean by becomes fragmented. So some folks think that even 7% fragmented is like really fragmented. And I would say, you know, 7% fragmented isn't that fragmented. You might have an index, or you may be talking about an index that becomes 50% fragmented in 2 days. So how fragmented is it getting? And then also, how many pages is the index? If the index is only 600 pages, I actually wouldn't worry about it at all. Like if it's, I actually would set this at personally 2,000. I'm not that concerned about indexes less than 2,000 pages because there's not that many pages and it is easy for them to become fragmented quickly. So make sure you're not looking at either a low level of fragmentation or a low number of pages. And then sort of say, okay, well, if it is really a large index, it's becoming this fragmented, you have the option when you do an index rebuild to bump the fill factor down slightly. So the default is letting them fill all the way full. I would bump it down to 95%. Now, the reason you don't want to go too fast, when you think of lowering the amount of pages full, you are saying, I want more empty space on the page. In a sense, you are saying, I want it to be 5% fragmented or 5% empty. There's kind of two types of fragmentation, and one is empty space in the page. So when you think about lowering fill factor, think of it as, I am purposefully fragmenting this a little bit in terms of empty space to try to keep the pages from getting out of order. Don't just immediately go to fill factor 80. Like, you're sort of like, don't rush one kind of fragmentation to avoid another kind of fragmentation. I would bump it down just a little bit and see, okay, how fragmented now are you getting in 2 days? Maybe bump down 5% more. But like, essentially the mistake folks make is they sacrifice page fullness to keep the pages from getting out of order, and you're kind of like, well, I've got, you don't want to just have more of one type of inefficiency to avoid a different type of worried about inefficiency. So you got to be careful. You got to find balance. But yeah, try to ignore, I would say, indexes less than 2,000 pages. And if it is just like 7% fragmented, I wouldn't worry about it that much either. Unless it's like 30% in 2 days, I'd let it go a little longer actually.
Perfect.
I take on it. And again, fragmentation. Somebody out there right now is saying she's wrong. That's okay. It's totally a controversial topic. I get it. I totally get it.
Great. Well, thank you, Kendra Little, for your time, and we'd like to also thank our sponsors. If you've liked what you've heard, Kendra will be presenting at the PASS Summit 2015, the pre-con SQL Server Index Therapy Session. Be sure to use discount code 24HOP15, that's 24HOP15, to save $200. And thank you very much for attending this session. Up next, we have Upgrade and Migration Planning BI features for SQL Server 2014 and 2016 with Paul Turley. Thanks again.
Thanks, everybody. Thanks for coming. Thanks so much.